The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now we'll take a look at naming compounds with polyatomic ions. Naming, we're going to be going from formula to name. Now, naming compounds with polyatomic ions is fairly simple. You name the cation, then you name the anion, but be sure that the ions combine in a ratio to give a neutral formula overall. And before we take a look and we answer, if you finish filling out the table here, 1.12, let's just go ahead and read our guide here. The guide to naming compounds with polyatomic ions. Step 1, write the name of the cation, use Roman numeral if necessary, and step 2, write the name of the anion. Fairly simple, right? Let's go ahead and take a look at an example here. So we're going to provide the systematic name for the following compounds. Looking here, we see that our cation is going to be copper, and we know that copper is a transition metal, and recall we stated that most examples when we're going to be where we have to name compounds, the elements that have transition metals most likely are going to have more than one charge, right? And we know that copper has more than one charge, thus we're going to need to specify, as it says here, the use of Roman numeral if necessary, right? So here Roman numeral is necessary. Now, so copper is our cation and carbonate here is our polyatomic anion. Now, if we recall the charge on the carbonate, right? The charge on the carbonate, let me just erase all of this stuff here. Right, the charge on the carbonate is -2, right? The charge on carbonate is -2. Now to obtain an overall neutral formula, as I had stated, we're going to need to balance that -2 with +2. Thus, the copper is going to have a +2 charge, and the name of this compound should be copper to carbonate. Let's go ahead and take a look at that now. Okay. Now moving on to our next example. Actually, before we move on to our next example, let's talk just for a moment. Let's just talk for a moment here about the barium nitrate substance. Whenever we have a substance which contains more than one polyatomic ion, such as barium nitrate, like a barium nitrate substance as we see here, which contains barium cations and nitrate polyatomic ions in a 1:2 ratio, then in those types of scenarios, the formula is written as follows, where the polyatomic ion is placed in parentheses, as we see here, and the number of polyatomic ions or ions present is just given as a subscript outside of the parentheses as such. So if you see the polyatomic ions written in parentheses, now you know what it stands for. Okay, now we can move on to our next compound here. Now, we know that aluminum is a group 3 metal and it has a +3 charge, right? And we also had just stated earlier in this lecture that aluminum is only going to have one charge, right, of +3. Thus, we can just go ahead and state the cation, that being aluminum, and we can also just go ahead and state the name of the anion, as it says here, just write the name of the anion, that's hydroxide. So the name of this compound should be aluminum hydroxide. Let's go ahead and take a look at that next. Okay, now let's move on here to our next compound. Now we know that we're going to need to use a Roman numeral for iron, right, as we've been doing thus far in this lecture. And our sulfate ion here, this polyatomic ion, what's the charge on sulfate? Sulfate was +2, right? Excuse me, -2, right? Thus, knowing, we'll come back there in just a moment. Knowing the charge on the sulfate is -2, and we have 3 sulfates, so that's a total of -6. To obtain an overall neutral formula, we're going to need to balance that -6 with a +6 charge with the 2 iron cations. Therefore, each iron cation here is going to have a +3 charge, knowing that the name of this compound should be iron 3 sulfate. And let's go ahead and take a look at that. Okay. Now, if we move forward, for our last compound here, again, we're going to need to use a Roman numeral, and the perchlorate, what's the charge on perchlorate? Well, if we recall, it should be -1, and perchlorate, as you see here, has a -1 charge, right? And because perchlorate has a -1 charge, and we have 3 of them, that's a total of -3. And to obtain an overall neutral formula, we're going to need to add the iron here is going to have the +3 charge. Therefore, the name of this compound here should be iron 3 perchlorate. Let's go ahead and take a look at that. Okay. Now that we've gone from formula to name, let's do a few examples where we go from name to formula, and we'll do that on the next slide.